All right, here are the solutions for the that quiz that many of you just took, that retake quiz. Um, so we've got some function, and we want to find the local max and min. So we take the derivative. Using the product rule, the derivative of the first is 2x. And then the derivative of the second function is e to the x squared times the derivative of that x squared, which is 2x. And we can simplify that. Well, let's not. Let's just pull out a 2x e to the x squared. And we're factoring that out since that exists here and here. So when we factor that out, what we're left with is 1 plus x squared. That's our derivative. And we want to know when does our derivative equal 0, because that's when we'll have a local max or min. So we get that either this equals 0, and the way that that's true is if x equals 0, or this equals 0. And a lot of people were a little frustrated by this, but if we solve this equation, we get x squared equals negative 1, and we know, well, we're not dealing with irrational numbers here, so this can never happen, so that's our only solution here. So then we make a derivative chart, and when we make a derivative chart, we're looking at 0, x less than 0, and x greater than 0. And we're putting that into the derivative, so this here. So when x equals 0, our derivative is 0. When x is less than 0, if we consider our two factors, that's my first factor, here's my second factor. This factor is always going to be positive because it's 1 plus of something squared is always positive, so this will always be positive, this can be negative. So when x is less than 0, that's negative, that's positive, so we get a negative number. And when x is greater than 0, everything here is positive. So therefore, we have ourselves a local min. So there is a min at x equals 0. What is the min? Well, it doesn't really ask that, but our min is our function evaluated at 0, which is 0. Putting 0 in for here gets 0. All right, that's the first problem. The next problem says use a second derivative test to find the local max and min values. So second derivative test, we find our first derivative. And we're going to set this equal to 0. So when we set it equal to 0, let's also factor out a 2. And now we're left with a kind of a medium hard factoring problem. The leading coefficient is not a 1. Well, my thought is, there's got to be, well, let's go through the process of this. The way that you can do this for sure is you say 3 times 2 gets you negative 6. And then you say what multiplies to get negative 6 and adds to get 1, this middle term, and that's 3 and negative 2. Then we split the middle term. This is stuff that you've seen before, I'm sure. So this is still 1x, but what it allows us to do is factor by grouping. So we factor each of those terms independently. So we get 3x times x plus 1 minus 2 x plus 1, and they both share an x plus 1, so we factor that out, and what's left is 3x minus 2. So what does x equal? X equals negative 1 and 2/3. Okay, these are our critical points, and we're going to determine whether they're maxes or mins by using the second derivative test. So the second derivative test says that if our second derivative of a critical point is greater than 0, that means our function is concave up and we're at a critical point, which means that we have a min. Similarly, if our second derivative of a critical point is less than 0, that means we're concave down and we're at a critical point, which means we have a maximum. So what do we need to do? We need to find the second derivative. Where are you, second derivative? So we're going to try to find the second derivative. We know how to do that. Our second derivative is 12x plus 2. And if we evaluate our second derivative at our critical points, so second derivative evaluated at -1 equals 12 times -1 plus 2, and that is less than 0. Therefore, this is a max. And our second derivative at 2/3. Oh, do we even need to do this? We have 12 times 2/3 plus 2. This is greater than 0. Therefore, it's a min. Now, while it says find the local max and min values, we're just finding the x values here. So what we'll say is there's a max at x equals -1 and a min at x equals 2/3. Okay, so those are the first two problems. Now let's do the trig problems. So it says find the global maximum value of the function on here. So the first thing, let's plug in our endpoints. So we've got when x equals 0, our function, that's a -√3 cos of 0 plus sine squared of 0. Well, that's just 0, and that's 1. So this equals -√3. And at pi over 2, we have -√3 cos of pi over 2, which is going to be 0, plus sine squared of pi over 2, which is just 1 squared. So this just equals 1. Now, those are the endpoints. We've dealt with them. Now we need to look at the derivative. So our derivative function, f prime, equals -√3 of negative sine of x plus, now we need to use the chain rule here. So let's think of this as sine of x squared. So the derivative of something squared, we're taking the derivative of this. Something squared is 2 times that something multiplied by that derivative of the inside, which the derivative of sine is cosine x. All right? Well, we've got a negative here and a negative here. Those become positive. We've got a sine and a sine, so let's factor them out. Let's set our derivative equal to 0, and we get sine of x or sine of x times √3 plus 2 cos of x. Well, we know that sine of x equals 0 when x equals 0 or pi, but only 0 is in that interval, so we can ignore pi. But we've already looked at x equals 0. So this doesn't give us a new solution. And here, if we solve this, we get cosine of x equals negative root 3 over 2. Well, knowing our trig tables, this occurs when x equals 5 pi over 6 or 7 pi over 6. Unfortunately, or rather fortunately, none of these values that make this statement true, none of those values are in our domain, so we can ignore it. Dun, dun. Therefore, what is our absolute max? Our absolute max is right here. So our max value is 1 at x equals pi over 2. There's our answer. And for the very last problem, similar in construction, but very different in terms of how we need to solve it. Let's see. So let's put in our endpoints. So we have f of negative pi over 2 I'm going to pause the video and just get this written out. Okay, so I just evaluated the function at its endpoints. We get negative root 3 and root 3. Now for the harder part, let's see about the derivative. So f prime of x equals root 3 cos of x minus sine of x. And we want to know when that equals 0. So in this case, because we can't factor anything out, since there's no factoring to be had, what we can do is we can create the equation, move sine of x over, and we get sine of x equals root 3 cos of x. Well, if we think about our unit circle here, so first things first, the interval that we're looking at is from negative pi over 2 up to pi over 2. That's the interval I'm looking at. And since sine of x needs to equal root 3 cos of x, both of these have to be the same sign. Like either sine is negative and cos is negative, or sine is positive and cos is positive. And that's only going to occur here. So now we've limited where it's going to be. And so then just kind of, if you don't know the answer right away, try the different functions. So try pi over 6, pi over 4, pi over 3. Just put them in there and see if you get an actual true equality. Or just know your unit circle really well and say that, at pi over 3, we know that sine of pi over 3 is root 2 over 2, and cos of pi over 3 is 1/2. So when we multiply it by this root 3, it'll make life equal. Well, I don't think it'll actually make life equal, but wouldn't that be nice? I hope you think that would be nice. Quality's good. So these are true statements. Good. So what we found out is that our critical point is at x equals pi over 3. So then we need to plug this critical point into our original function. And when we do that, and when we're very careful about things, our function evaluated at pi over 3 equals root 3 times sine of pi over 3 plus cos of pi over 3. And now we're familiar with these values. So we get root 3 times root 3 over 2 plus 1 over 2, and that simplifies to 3 over 2 plus 1 half, which is 4 over 2, or just 2. And this value is bigger than that value and bigger than that value, so this is my max. So therefore, we are now done. Hopefully there'll be a retake option next week, and hopefully we can do super.